This is an AQA Psychology A-level revision video for the research methods topic area of inferential statistics. So inferential statistics just refers to the main part of statistical analysis that a researcher would carry out in order to find out what their results actually show and whether they have found a significant relationship or difference. So in order to understand inferential statistics in more detail, you need to have some underlying knowledge of hypotheses and the way research is carried out. So there are 5 questions on the board for you to have a think about. In 5 seconds, I will go through the answers. So now is the chance to pause the video and have a think. Okay, so as said, before we do anything statistical, we need to recap the importance of a hypothesis. So a hypothesis is a statement of prediction. There are 2 main types of hypotheses, which are your null and your alternative hypotheses. We have a null hypothesis because we will predict nothing will happen. There'll be no relationship or no difference, and that is the one we are trying to prove wrong. We then must write an alternative hypothesis that needs to be directional or non-directional, and that's the one we aim to prove right. So just a recap of the definitions, if you feel like you need to write them down, now is your opportunity. Okay, so directional hypotheses can be used if there is previous research in the area that tells the researcher for certain that the outcome will occur. So if it's research that indicates there's a positive correlation between 2 things, then the researcher doing their own research can also predict that direction. Non-directional hypotheses should be used if there's no research or if the research is contradictory. So if one study found a positive correlation but another found a negative correlation. In terms of why we use inferential statistics, they allow us to say whether a difference is significant or a relationship is significant, and that's ultimately what a researcher is aiming to find out throughout their study, throughout their research. So in the past, exam questions have come up, short answer questions, sort of 2 or 3 marks as to why inferential statistics are used. So it's really important that you understand the 2 main reasons. Other than being able to determine significance, it allows you to accept your alternative hypothesis or reject your null hypothesis. And it increases the scientific credibility and objectivity of research, because a statistical analysis is something that's objective, that the researcher isn't necessarily able to bias as long as they use their actual data. So in terms of deciding which statistical test to use, you have to know a number of different things. So the things in green are things that you would have covered earlier on in the course. So type of research design. If it's related, so your design is a related design, that will be repeated measures and matched pairs. And that is because your data is related, i.e. you are getting information from the same or similar participants, whereas an independent groups would provide you with unrelated data because you're comparing 2 different groups of people. Also, things to read for in the stem from the exam question, as it says here in the purple box, is it a test of difference? Is it an experiment that's used a repeated measures or an independent groups and has given the 2 different tasks of the independent variable or multiple tasks of the independent variable? Or is it just looking for a relationship? Is it a correlation? Often students struggle to argue this third D, and if it's a test of difference, it's an experiment because they have manipulated certain things, then you would say the third reason is because the researcher is looking for a difference between whatever is in the question, in the STEM, or if they are looking for a correlation, a relationship between, and then you would state the 2 covariables from the STEM. So moving on to the third D, it's the level of data or level of measurement is what it's actually called, but it's the type of data that the researcher collects as part of their dependent variable. So there are three types, three levels, which are nominal, ordinal, and interval. So you can pause the video to check your understanding, just get a brief definition of each of these, and in 5 seconds I'll go through the answers. Okay, so nominal data is categorical data, data that is put into categories, and typically you would record the score in each category. So I could record gambling or not, and I could tally how many people gamble, how many people don't. Or I could tally what newspaper people read, although that's certainly something that's ceasing to exist nowadays. But I could tally how many readers of the Daily Mirror there are, how many of the Sun there are, how many of the Guardian. That's put into named categories, and you are counting the quantity in each category. So you are recording its frequency. Ordinal data is data that can be ranked, it can be put in order. Obviously GCSEs aren't graded on letters anymore, but it's just an example. So the grade you get in your A levels can be graded from A star to a U. So you can be ranked, you can put in order the highest to the lowest grades and who got them. However, it doesn't have a fixed scale. And using this example, an A star in psychology is around, say, 90%, but in other subjects like geography, an A star might be 60%. So there's no fixed agreement on what each order, each ranking equates to. And that is important because the last level of measurement, interval, is arguably the most powerful. It's similar to ordinal. You are ranking it, but with a scale, an objective scale that everybody agrees on across the world. So things like time or distance or weight in kilograms, they have fixed units that don't deviate. And so if something is interval, it is also ordinal. And so you can make that argument if you're unsure of whether it's interval or not. Or, for example, in a correlation, if one covariable is interval but the other is ordinal, you have to choose ordinal. Otherwise, the statistical test will be too powerful for one of the covariables. So if you've got one ordinal, one interval covariable, instead of going for a Pearson's, which would be for interval data, you would best off be going for Spearman's because one of them is ordinal, which is considered a lower level of data. So those are your three levels of measurement or types of data to summarise your 3 Ds. That is important because depending on what you learn and how you learn the statistical test and how you memorise each statistical test, that will affect which statistical test you choose if you're given an exam question where you have to select a test. So here we have the table that I would encourage you to learn in order to know the reasons you would use each test and therefore being able to read the STEM, read the information in the exam and choose the correct test. So I always teach, and it might be worthwhile just pausing the video and copying out this table if you need to. In 5 seconds, I will go through my little mnemonic which gives you the first letter of each statistical test and in the order of this table. Okay, so the little mnemonic that I would recommend for you to learn is Simon for sign test, Cowell. Simon Cowell considerately wants more singers receiving unbelievable pay. You need to learn that the table goes in order of nominal, ordinal, interval along the left, and that your related, unrelated, and then correlations are along the columns to the right. Also, these two are tests of difference and correlations are tests of relationships for your third D. So you've got all Ds. Is it a test of difference? Let me just highlight that so it's clear. First D, is it a test of difference? What is the level of data being collected in the dependent variable and what type of design has been used if necessary? Okay, piecing this all together then, what we need to look at now is probability, because we will look at how this all slots into statistical tables shortly. So you will need to know about probability values, and in psychology we typically use the 0.05 level, which means there's a 5% probability our results have been due to chance or random variables. Now, the p-value is always 0.05 in psychology, unless in the question it states otherwise. You always assume it's the 5% level, and that's because 95% certainty is enough in psychology. If you were using like biological or research into medicine, which can appear in psychology, you need to use a higher p-value, like 0.01, so you mean 99% sure, or 99.9% sure, which is 0.001. But typically the conventional level, and they might ask you why we use that p-value. It's the conventional level, and it also balances type 1 and type 2 errors. It balances the risk of them. So let's have a little look at what we mean by type 1 and type 2 errors. So you can pause the video if you want to check your knowledge, a definition of type 1 and type 2 errors, and anything you know about them. In 5 seconds, I will explain. So, in order to remember which one's which, I encourage you to think of this. Type 1, if you turn it, you just add one line and it turns into the letter P. Type 2, add one line and it turns into the letter N. That is because a type 1 error is a false positive and a type 2 error is a false negative. In the context of psychology or in statistics, that would mean a type 1 error is likely to happen if your p-value is too large, too lenient. You're likely to get a false positive and think you've found a significant difference if you only account for 90% certainty, so 10% due to chance. On the other hand, a false negative is more likely if the p-value is too small and you're too strict on yourself. So something like 0.01 where you're 1% due to chance and 99% certainty. If you want to be that certain, you are likely to have a false negative. So by definition, your false positive means you've wrongly accepted the alternative hypothesis, thinking you found a significant difference, but you haven't. And a type 2 is when you wrongly accept your null hypothesis. You think that you haven't found a significant difference, but you have. Okay, we're working our way through all the different parts of statistics. So next you need to be able to comment on what a statistical test shows. And that's where you need to be able to read from what is called a critical values table. Critical values tables come in lots of different formats and they look in lots of different ways. The exam board tend to sort of use the same format, but you can see how it varies depending on the question. For example, that's one critical values table for Pearson's. And then you've got another one for Spearman's Row. So same font and same sort of organisation, but very different information. So what happens is the only test you have to calculate for AQA is the sign test, which is good, and that's how I will end this video. But in all stats tests, you get a calculated value. That is the thing that the researcher calculates, the data of the participants, the information they've collected. Then you need to compare it to a critical value, which is calculated by statisticians and is given to you in the exam. So that is what this looks like and is called your critical values. Now, in order to read from the critical value table, you need to know three things. You need to know what p-value is used. It's always 0.05 unless the question states otherwise. You need to know your hypothesis. Was it one-tailed, directional, or was it two-tailed, non-directional? Critical values tend to be higher for one-tailed tests because you've got to be more certain because you are predicting a specific outcome. And then you need to know the value of n, which is your sample size. Now, the problem here is that I call it value of n, but some statistical tests call it degrees of freedom. And it will say DF if it is degrees of freedom. That requires a slightly different rule. You don't take your sample size exactly. It's usually your sample size minus 2, but the rule will always be given to you at the bottom of the critical values table. So just make sure you really explore the table and you highlight the important information before you progress with the question. So we compare the critical value, which we get from the table, reminder here, with our calculated value, and that will be able to tell us whether our hypothesis is significant or not, as shown by the rule here. So I don't have any values in front of me, but we are going to look at a question in a moment. So the point here that you need to understand is one-tailed test is here in the table, two-tailed test is here. So you need to find out, is your hypothesis directional or non-directional? You always use the 0.05 level unless the question states otherwise, which is here for your one-tailed, but it's here for your two-tailed. So you've got to be very careful where you're reading from, and that depends on the information you get in the question. Then you need to know your value of n, which is your number of participants, or if it's degrees of freedom, there'll be a rule given around here that you use to then calculate what n actually is. So if once you've done all of that analysis, which we're going to practice shortly, if your result is significant, you must reject your null and say the difference was not due to chance. If, however, it turns out it's not significant, you accept the null. So if you're rejecting the null, you're accepting the alternative. If you're accepting the null, you're rejecting the alternative. It's always good to state both if the question requires you to. So here we go. A researcher investigated whether there was a correlation between the number of hours slept and how well rested students felt. They used 18 participants. They asked participants to rate on a scale of 1 to 5 how well rested they felt and how many hours did you sleep. Then there was a positive correlation found. Jot down those key things that I've highlighted and let's work together through the question. So question says, and the key things are here, the calculated value was 0.395. So that's what we need to compare against this table. So we've got to identify the appropriate value from the table and explain our choice. 4 marks. 1 mark for getting the right critical value. 3 marks for explaining how we got that far. So we know it was a positive correlation. We know it was a one-tailed test. We know then it's this 0.05 because we always use that and the question hasn't told us to use a different p-value. They've said the 5% level. Final thing we need to know is what our n is, and there's no rule at the bottom of the table to suggest anything needs to be done with the sample size, so we use 18. Therefore, our value is 0.401. So 0.401 gets you 1 mark for identifying it, and then stating this is because it was a one-tailed test at a 0.05 level for 18 participants. Obviously, you would highlight this in the exam paper, but you need to state it in your answer to get those 4 marks. Then the next question is explain whether the researcher's hypothesis should be accepted. So when they don't use the word null or alternative, just assume they mean alternative. Should we accept it? And we need to refer to the critical value in our answer for 2 marks. So that's where we need to follow this rule. Calculated value of rho, which is 0.395, needs to be greater than or equal to 0.401. Little bit of quick maths, little bit of thinking. No, it's not. It's smaller. So the alternative hypothesis should be rejected. So it should not be accepted, 1 mark. This is because the calculated value of 0.395 is smaller than the critical value of 0.401. Now, looking at how we calculate the sign test. So the sign test, 3 Ds for the sign test. related data, so repeated measures or matched pairs, nominal data, categories, test of difference. You have to be able to calculate the sign test. So I've got 9 steps on the next screen. They're not necessarily all needed, but it's good to just know them and practice, even if you create your own numbers and your own data, just to have a feel for how the sign test should be done. So I'm going to give you the opportunity to pause the video now. In 5 seconds I will move on, but these are your steps. So before you calculate the sign test, you need to make sure, does it meet all the 3 Ds? Is it nominal data? Is it related design? Is it a test of difference? If they're going to ask you to calculate it in the exam, then it will meet those conditions, unless the question says why has the wrong test been used. So you need to read the information just like we've practiced. Was your hypothesis one or two-tailed? Because that's going to affect how you interpret your results in stage 8. You need to calculate the difference between your conditions. So you will have condition 1 and condition 2 because it will be matched pairs or repeated measures. So you'll have 2 lots of your data. Calculate the difference. If the difference is positive, you put a plus. If there's a negative difference, it's a minus. If your participant remain the same, it's an equal sign. Important to remember for your calculated value in the sign test, you count the number of each sign, you don't count the equals. If there's no difference, you've got to remove them from your sample size. So that will affect your N, which will affect what you're reading from the table. Then you need to learn this rule. The lower number of signs becomes your calculated value. It doesn't matter which order you take away from because it's a sign. If you take it away, if you do condition 1 minus 2 and you end up with a positive, when you do condition 2 minus 1, you'll end up with a negative. It's the lower number of signs and you'll always end up with the same lower number of signs no matter which sign it is. That's your S value, and once you've got that, you find your critical value and interpret your results to write up. So, a worked example. There's going to be a difference in energy levels of participants when they drink coffee compared to not drinking coffee. So our IV is whether they drink coffee or not, and the DV is energy levels. I don't care about operationalising them. It's just a very quick example to apply to actually doing the sign test. So there's 7 participants. There will be a difference, meaning that this is a two-tailed hypothesis. So what you do is you calculate your difference. So you can do condition 2 minus 1 in this example. So it's 9 minus 7 gives you 2. And you work your way through your columns till you get all of your data filled in. Then the important bit is the sign column. So there was a positive difference of 2. This person, if you look in this order, they've gained energy drinking coffee. So it's a positive sign. This person has stayed the same, equals. So we're going to lose 1 participant from 7. Keep a note of that. And then you've got your minus signs as well. So you then count the number of each sign and you use your lower number of signs as S. So we've got 1, 2, 3, 4 plus signs. We don't use the equals. S is not 1. We ignore the equals. And we have 2 minus signs. So S is 2. We then have to find our critical value, which is putting everything together from what we've already done in the previous parts of the video. A reminder, we need to know our significance level or p-value, whether our hypothesis was 1 or 2-tailed, and the number of participants minus any non-changes or equal signs. So a reminder of that for this specific example, because I have gone very fast through it, is our N was 7, but we had 1 equals, so 6. It was a 2-tailed hypothesis, maybe? Yes, I've done that wrong. It was a 2-tailed hypothesis, and our p-value was 0.05. So when we read from the critical values table, let's do this with a highlighter. It's the level of significance for a 2-tailed test for 6 participants at the 0.05 level gives you a critical value of 0. So let's compare them. Critical value of 2, calculated value of 2, critical value of 0. The rule here is at the top of the table. Critical value S must be equal to or less than the stated value, while it was S was 2 and the critical value was 0. So it's not significant. So when you write that up, you can use this frame below. And this is a final opportunity to pause the video. Just fill in that frame with the information that we've done on this example. Rewind and go back if you need to remind yourselves of what we have done, but most of it is on this table in front of you. And in 5 seconds, I will read through the answer. Okay, so at P is less than or equal to 0.05 for a two-tailed test, the calculated value of S is S equals 2 was more than our critical value of 0. Therefore, we must reject our alternative hypothesis and accept a null hypothesis. There was not a significant difference in participants' energy levels when drinking coffee compared to not drinking coffee. You've got to regurgitate the hypotheses at that point, that long line there. So that concludes the end of this video. That is a whistle-stop tour of the bulk of statistics. So you need to be able to choose the right statistical test and justify your choices. You need to be able to calculate the sign test, and you need to be able to interpret and write up results. You also need to be able to know and explain the difference between type 1 and type 2 errors in the context of p-values, whether your p-value is too small or too large. Remember, the 5% level is used in psychology. It's the conventional level, and it balances the risk of a type 1 and a type 2 error. Thank you for watching. I hope you found it useful.